All right, gentlemen. Okay, so this is the information that you gave me. And, well, beforehand, I want to apologize for any uh, background noise and interruptions that we have. So, anyways, okay. So, okay, baby. So now I already forgot what I was going to say. Okay, find y of t. And this is the initial part of the problem. This was the graph. And let me get. Sorry, I wish I was more prepared. Okay, that's better. Okay, so here is a solution to y equal to f of t, which is the one that we're actually trying to find here. Okay, now this solution, before I continue, this solution is when time is equal to 30, and you have this y value. And y is equal to L. L is basically, if we think of it like a population type of situation, the carrying capacity. And so this is the inflection point. And so the inflection point is, for a logistic equation, is always going to be halfway or half of the carrying capacity. Okay? All right. So now we want to solve for this. And they gave us this. Now, I forgot, what was the question? They said, use partial fraction integration to express y of t. Okay, here we go. Wish me luck. So I need partial fraction. I need partial fraction. So I need to do some integration. So right now, this is not in a differential equation form. This guy right here is, and we can do some substitution. We can substitute this in for g of y. So dy dt is equal to 3 over 20 times y times 20 over 3 c minus y. Okay? And so this is our g of y. Okay? And so now let's see. This says goodbye to that. That says goodbye to that. And so what do we have? We have dy dt is equal to y times c minus y. Okay. And so now, how are we going to have partial fraction integration? Well, when I put my y's together, I'm going to have 1 over y c minus y dy is equal to dt. Okay? And so then I can see that I'm going to integrate this, and I'm going to probably need to use some partial fractions here. So they said a over y plus b over c minus y. And we want to find out what our a and b are. Okay, so then if I have a times c minus y plus b times y, it has to equal 1, right? Because when I do common denominators, this expression will be equivalent to my numerator. So then if we say that y is equal to 0, when y is equal to 0, if I put 0 in for that, then what I'm going to get, there's going to be no more b's, and then it's going to be a times c is equal to 1. So that means a is equal to 1 over c. Okay? And so then I'm going to scoot this over here so I can save paper. And so now if I say y equal to c, because that will make this 0. So y is equal to c. So when I put c in for y, then that makes the a expression go away. So that's going to be 0. And I'm going to have b times c is equal to 1, because I'm replacing y with c. And then I'm going to have b is equal to 1 over c. So now I have my a and b. So I'm going to take those and now put it into this guy right here. So I'll do it like this. 1 over y c minus y dy is equal to 1 over c, that's my a, and my a was over y, plus my b is 1 over c, and my b was over c minus y, dy is equal to integral of dt. Okay? All right, so then I can factor out the 1 over c integral 1 over y plus 1 over c minus y dy is equal to dt integral. And so now here I have this coefficient. So I'm going to have 1 over c. And now I'm going to integrate this. This is going to be natural log absolute value of y plus natural log absolute value of c minus y. But now I'm going to change that plus to a minus, because if you remember using the chain rule, if I took the derivative of this, it would be 1 over c minus y. But then you have to take the derivative of the inside, because I'm using the chain rule, and the derivative of y would be negative 1. And there's no negative there, so I need to counter that with a negative. Here you go.
Thank you.
You can have it back. Thank you, baby.
Yeah.
All right. Is equal to what? Oh, t plus, well, now I'm not going to use c because it can get confusing with the other c that we have. And so I'm just going to try to stick to their variables. I'm going to put k so that it's kind of in line with our solutions, okay? So that's my additional constant. All right. Now, give me a second because I need to tear this out. All right. Okay, so let me rewrite this. T plus k. Okay, so now we can put that c over there. So I have natural log absolute value of y minus natural log absolute value of c minus y is equal to c t plus, and they left it as k. You can put a different variable if you want, because technically we're multiplying the whole thing. But a constant, c times a constant is a constant, okay? So that's why they left it as k there, okay? So it's still going to be a constant, although I'm using their terms, but I am, to be honest with you, a little uncomfortable calling that k again. I would call it a different letter, but just so that it's easy for you to go back to from my work to their work, I'm leaving it like that, okay? Okay, and then now so now at this point we want to solve for k. That's generally what we do, okay? And so in order to solve for k, we need to have a known point. And I'm trying to look for my other pen. There we go. Okay, so if we go back to oh, that's beautiful, baby. This guy right here. Like right over here. dy dt is equal to y c minus y, like this. Okay, now this can also be rewritten as dy dt is equal to y. And then if I divide inside here by c, I'll have 1 minus y over c, like that. And yeah, hold on 1 second. And then I would have to have a c over here. Yeah, okay. So now the reason why I'm doing that is because hopefully you can recall that this is similar to our the original logistic equation that we used, where what's in the denominator is our carrying capacity. Which means that this c right here matches up with this L right over here. So I don't think that they were very clear in their steps expressing that to you. So I'm placing that c with the L. At this point it was a variable. Now using this equation and transferring it to this so that you can easily see that the denominator, which is our carrying capacity that we're used to seeing, is equivalent to L, which then means the point that we have is 30 comma c over 2. So we're going to use 30 comma c over 2 as the point that we're going to use to solve for our k. Okay, so now I'm going to replace all my y's with c over 2, and then all my t's, which there's only one, with 30. So here we go. So we'll have natural log absolute value of c over 2 minus natural log absolute value of c minus c over 2. And also, you could put these two together as a fraction because that's the log of logs, but I think they kept it separate. Maybe did it later on. Yeah, they did it later on. But I'm going to try to stick with theirs so that you can follow along easily. And then we have c times 30 plus k. Okay, so that's me substituting our known point into there. And it looks like we still have a lot of variables, but that's okay. We'll be fine. All right, so now natural log of c over 2 minus, now c minus c over 2 is c over 2, right? It's like, well, I mean, if we get common denominators, then this would be over 2, so we have 2c over 2 minus c over 2, and so then that is going to leave us with over 2, 1c over 2, so, right, we're just subtracting a half of it, so that's going to be natural log c over 2 is equal to 30c plus k. That's k. All right, and so then when you subtract that from each other, that is 0. Had these been divided, then it would be natural log of 1, which is also 0. So that means 0 is equal to 30c plus k, and so that means k is equal to negative 30c. Yeah. All right, I know, I'm so excited. Huh? Yes, this is a very long and torturous problem. It is, yeah. Mm-hmm. Yeah, and I'm certain that if you guys understand this, that you will do superbly on the AP test. Now
think of it as higher order thinking.
Think of it as higher order thinking, she says. See how many interruptions we have. All right. Now I lost track of my spot. Oh yeah, I have to take this and put it in Aki. Natural log of y minus natural log c minus y is equal to ct minus 30c. Yeah. Okay, and so now I'm going to put this together as a fraction. So I'm going to have natural log absolute value y divided by c minus y is equal to cte, not yet, 30c. And then we always do what I enjoy doing, big E, goodbye. And so I have y minus c minus y is equal to e to the ct minus 30c. And I think we're getting closer to where we want to be. We need to get y by itself in terms of t, our variable t. So the first thing we're going to do is multiply out c minus y. So y is equal to e to ct, there we go, minus 30c, c minus y, like so. And then you're going to distribute this, like so. This gets ugly, and then it reduces. Y is equal to, here we go, c e to the ct minus 30c minus y e to the ct minus 30c. Okay, now I'm going to put my y's together over here. So I'm going to have y plus y e to the ct minus 30c is equal to c e to the ct minus 30c. I sure hope I'm not making any boo-boos. I'm going to double check before I proceed any further and mess something up, because you know how I am when it comes to like this kind of math. Simple math, very challenging for mommy. Simple math is challenging. For mommy it is. But there's a plus here. How did there end up being a plus there? Oh no. I don't know. No, this looks good to me so far. Oh well, I already lost where they were, so I'm going to just continue on. Okay, and so now what am I doing next? I'm going to factor out the y. So when I factor out the y, it's going to leave me with 1 plus e to the ct minus 30c is equal to c. Shh, Hannah, baby. Beautiful. Okay, and then I'm going to bring it over here. So what is y in terms of t? It is equal to c e to the ct minus 30c divided by that 1 plus e to the ct minus 30c. And I sure hope that's the answer. Let me look before I go highlighting this thing. I'm missing a negative someplace. Well, no. This is negative. What the heck? I missed a sign someplace, it seems. Or they're doing two different situations. Oh, I have one part correct, and apparently there's another solution. Well, for y greater than c. Oh, they divided it. Okay, so let me explain that. I didn't even look at that part, but I'll explain this. Okay, which Mrs. Wynn would not get this right because I didn't look at this part. But let me explain this to you. Okay, so they stated this because as long as your y's are between 0 and L, which we already discovered L is C, this is going to be a positive increasing function. It's going to be increasing, right? Okay? And your y values are going to increase. Should your y value, your initial y value, be above C, so let's say y is greater than C, then what's going to happen? This is going to go down. Okay? And so now they rewrote it where they rewrote this. Right here. Okay. So when we had this expression, which we stole from, where's my other paper? Which we got from substituting g of y into our dy dt. Sorry, this way. Wait, let her go. She needs to go potty. Okay. Now, here our dy dt is positive. If our y values are above c, then our dy dt would then be negative. Okay, so if I want to talk about my y values when they're negative, I would have this, which what they did is they took that and put that in here. And so then you would have y, and then it'll be y minus c. So then if I take that and redo not most of it, but redo, let's see, for what step? Y minus c. I guess about here. You would just switch this y minus c instead of c minus y. And so that'll just switch a few things around. So you would restart and make a solution for y greater than c you would start from here. Y divided by y minus c is equal to e to the ct minus 30c. And then you would proceed with the same algebraic steps to get to your solution, which is just going to switch some signs here. But overall, I think you'd get quite a few points if you made it this far, which I don't think that they're going to have a problem like this on the test, but at least I pray they don't have a problem like this on the test. Okay, well, that's the end of that. Hope it helps. Take care.